Hey, welcome back. So a new chapter today. We're starting our unit on bonding, and we'll start with ionic bonding. So a little bit of background here. Compounds are substances that have atoms from more than one element, and those atoms are chemically bonded. So far, we've only looked at one type of element, an element of aluminum, or an element of nitrogen, or an element of oxygen. And starting this chapter, we're going to start to combine them into compounds. And that's how you make things like water, H2O, two H's and one O. So there's three types of chemical bonds: ionic bonds, and this is when a metal bonds with a nonmetal. So remember this from the previous chapter. Metals are on the left of the stair-step line. They're shown here in red. They're most of the elements on the periodic table. And if you're working with anybody on the left of the stair-step line, you're working with a metal. And your nonmetals are the blue over here on the right of the stair-step line. There are not nearly as many nonmetals. Keep in mind, the noble gases very rarely bond. We won't see that in this class. So really, we're only working with a handful of nonmetals, just this upper right-hand corner here. And again, you can exclude the noble gases. Generally, when we have an ionic compound, we call it a formula unit. Another big type of bond is a covalent bond. And this is when two nonmetals bond. So here again are our nonmetals, upper right-hand corner. If you have two elements from this area of the periodic table, you have a covalent bond. We call these compounds molecules. You've probably heard the term molecule before. It is very specific to a covalently bonded compound. So two elements, two or more elements, from the right side of the periodic table here. And then finally, a metallic bond. This is when you have two metals that bond together. We won't work much with them this year, just with our time constraints and whatnot, but metallic bonds are called alloys. So when you have two metals bond, it is a metallic bond, and we call those alloys. Alright, so starting off today, we are focusing on our ionic compounds, and these form when a metal transfers its electrons to a nonmetal. So it's called ionic because you're forming ions. The metal loses or gives up an electron, and that electron goes to the nonmetal, which forms an anion. Properties of ionic compounds are high melting points, which means they're solid at room temperature. High boiling points, so very similarly, you have to apply a lot of heat, a lot of temperature, a lot of energy to get ionic compounds to turn from a solid or a liquid to a gas. They're generally very hard. So rocks are ionic compounds. You can think of the rocks under your feet. They are ionic compounds, and they have a high conductivity when they're dissolved or melted. So they pass electrical current really easily when they are dissolved or melted. Not a whole lot of melted rocks. Generally, when we think of ionic compounds in their liquid state, we think of lava or magma coming out of a volcano. Most of the time, though, salts will dissolve. Like table salt, you put it into water and it dissolves, those compounds come apart. So it's not necessarily in a liquid state, it's just dissolved, it's aqueous. And when that's the case, it's really good at passing electrical currents. We always show that with a light bulb. Light bulb's off in plain water, but you throw some salt in there, and those two nodes will pass electricity through the dissolved salts, and you'll have the light bulb turn on. And also, ionic compounds will shatter when force is applied. So you see an ionic compound here, and if you hit it with a hammer, it's going to break and crumble and fall apart. Alright, so before we get to bonding, we have to understand Lewis dot structures. So the idea is that all elements in the same group, so remember groups are up and down, all the elements in the same group are going to have the same number of valence electrons. Well, a Lewis dot structure shows those valence electrons. So everybody in group 1 has one valence electron, and so we show just one dot. Everyone in group 2, the alkaline earth metals, they all have two valence electrons, so we show two dots. I like to put them together, start on the right, and then I put them together, and the reason why I put them together is that those are the s2 electrons. Up arrow, down arrow. Those guys are paired together. We skip over the D block then. So that's kind of what this break is here. We're missing the D block. We're not going to work much with the D block elements in bonding, so we're not too worried about it right now. Skip over the D block. Here's the P block. Boron, aluminum, gallium, those guys all have 3 valence electrons. So there's the 2 s2 electrons. And then here is that first P dot. Now for carbon, he's got 4 valence electrons that are in carbon's family. And you can see now I'm starting to do lone dots, dots by themselves. And the reason for that, again, think of up arrow, up arrow. We've got 2 empty orbitals, or 3 empty orbitals, and a p orbital. So there's nitrogen, and there it is, up arrow, up arrow, up arrow. That's why I've got these dots separated, even though I started by putting the first 2 together. Oxygen has your first pair of p orbitals, up arrow, down arrow, and you still have up arrow, up arrow. Fluorine has 2 paired p orbitals, up arrow, down arrow, just an up arrow. And then finally, we get to the noble gases, and they have that full octet, all 8 electrons filling up their outer shell. With the exception, of course, being helium, who only has 2 electrons. His first level is full. It's just that the first level can only hold 2 electrons. All right, so now to the fun. Here we go, sodium chloride. Start by drawing the dot diagrams. We need sodium and we need chlorine. Don't be fooled by that IDE. We'll get to that in our next unit. That IDE just lets us know that it's an ion, not the atom. But it's still chlorine. Here's chlorine. Sodium has 1 dot. Chlorine has 7 dots. So you kind of see chlorine's missing 1. Sodium would love to give up 1. So what do? Well, we draw a line that shows this electron will leave sodium and travel over to chlorine. We're going to redraw that diagram. Make sure you have an arrow. There we go. Must show that arrow. This is a reaction. If you don't have the arrow, you're missing a point. So make sure you draw that arrow. We have a reaction occurring. I draw the sodium. I put it in brackets. Why do I put it in brackets? Well, because it has a positive charge. It lost an electron. It is now positively charged. Chlorine, here's chlorine. Again, I've got them in brackets. I use an X to represent the electron that transferred. So there's the electron that transferred over from sodium. You don't have to use an X. I just like to. It helps me to see exactly where that electron is. Chloride has a negative charge. He gained an electron. Remember, electrons are negatively charged. So if you have an extra one, you're going to have a negative charge. Make sure that you have those charges. Those charges are the bond. Without those charges, this doesn't stick together. There is no bond. It's kind of like magnets. But without those charges, these aren't going to stick together. So you have to have the charges, have to have those valence electrons, have to have that arrow. Let's take a look at another one, calcium chloride. So here's calcium. He's got 2 valence electrons. Here's chlorine again. We've already worked with them. He's got a 7 valence electrons. And he's looking for 1 more, and there we go. Calcium has it, so we draw a line that gives it to him. Wonderful. Except that calcium has 2 electrons. He's only gotten rid of 1 of those 2. So, what do we have to do? We have to add another chlorine. Can't give both of those electrons to the first chlorine. That wouldn't work too well. This chlorine only wants a total of 8. He has 8. We need to add another chlorine. There we go. He can take the second electron from calcium. There's our arrow. Don't forget about that arrow. And then here's calcium. 2 plus. Why 2 plus? Well, he gave up 2 electrons. 2 electrons left him, so he has a 2 positive charge. I've got my 2 chloride ions on either side. They both have a negative charge to represent the fact that they are bonded negative to positive, negative to positive. It's only that electrostatic force, that positive negative, that keeps these guys held together. There's my X representing the electron that this guy got. There's the X that represents the electron that this chlorine got. Sometimes you're going to have atoms where you have 3 or 4 on one side, and that's okay. Just keep going until everyone is satisfied. The metal has gotten rid of all of his valence electrons. The nonmetal has gained a full octet. Again, if it means you have to add another atom, it happens. Sometimes you'll have numbers where you have 2 or 3 or sometimes even 4 atoms in order to get it balanced out. And that's fine. That's how it works. Hey, practice makes perfect. I'm sure you have a homework to go practice. Thanks for tuning in. We'll see you next time.